So I can take this one slides. So let's see, we will see here how to form the images using the convex lens. So as we had defined different positions with respect to this lens, so we had seen that there is an optical center. We'll mark the optical center here. So by joining these 2 points, you get the optical center O. The optical center O. Then you get the points F, which is the first principal focus F1. Then here you have double of this, that is 2F1. On this side, you get the distance F2, and here you have 2F. So the distances, focal length on both the sides is same. So OF1 and OF2, the distances are same. So you can't say that the lens has two focal lengths. The lens will have one focal length only. So you have OF1 will be equal to OF2, which will be equal to the focal length of the lens. So focal length will be the constant. Yesterday we had seen the image formation when the ray of light comes from infinity. Today I will be taking a ray of light a little close to the lens, but beyond this 2F. So if you take an object which is beyond 2F and try to form its image, so here you have the object placed beyond 2F, and now we take two rays of light which pass, one of them pass parallel to the principal axis, so it passes like this, and the other ray of light, it passes through the optic center and hence passes undeviated, so something like this it passes. So you can see we have taken two rays of light. One of them is passing parallel to the principal axis. The second ray of light is passing through the optic center. So the ray of light which passes through the optic center, it passes undeviated. And the ray of light which passes parallel to the principal axis. So after refraction from here, this ray of light passes through the principal focus. So it passes through the principal focus, and hence we observe here that the two rays of light, they meet. Here you have the two rays of light, they meet between F2 and 2F. So here, so you have here. So for the, since we observed that all the rays of light, they were coming from the tip of the arrow. So you have AB, all the rays of light, they were coming from the tip of the arrow, and they meet here again between F2 and 2F2. So where they meet at this point, we will have the formation of image, that is tip will be formed. So we will have our A dash on the principal axis and B dash here. Now we can list out the characteristics of the image which is formed when the object is placed beyond C. So here we had placed the object beyond 2F. The object was placed beyond 2F, and we have some image characteristics. So can you tell the image characteristics here?
It is diminished and it is formed between F2 and 2F2.
Okay, very good. So first point. Okay, what can you say about the nature of the image?
Real and inverted.
Yes, the nature is real and inverted. You say nature is real and inverted. And what about position? We see whenever you are telling about the characteristics, you have to tell these three things: nature, position, and size. So we observe here that image is formed. You see here, image is formed between uh, image is formed between F2 and 2F. F and 2F. Image is formed between F and 2F, that's the position. Then you have the size of image.
Sir, it is diminished.
Yeah. So the size of image is diminished. So whenever you are asked about the image characteristics, do tell in points. You have the nature, position, and size. So nature will be here. For this case, you have real and inverted image. You have position and size. Got it? Now, can you try to draw the array diagram? Have you drawn this array diagram? Just take 2 minutes to draw the array diagram for this. Take a ray of light parallel to the principal axis. That ray of light passes through the focus. Take a ray of light passing. Okay. So, the next we can draw for the object to be placed at 2F. So let's take here now object to be placed at 2F. Okay. So draw its optic center and with proper measurements make your F and 2F. If you do not use proper measurements for F and 2F, you will be getting errors. So I tell you, generally you should be using here your either you should use your compass or your scale to get your proper measurements. That means you have to arrange it properly. Aryan,
Sir,
Dharya, yes.
Yes.
So see, the distances should be the same. That's why just take it an approximation that on both the sides you are marking your F1 and 2F1. So mark them with just an indication that it should be almost equal. So see here I am taking the help of a ruler to take mark your F1 and F2. So see your F1 and 2F1. In the similar way you will be taking, here I have taken it to be approximately 3 centimeter. Okay. Focal length I have taken approximately to be 3 centimeter. So in the same way, you will be marking on the both the sides like this. Dharya, are you doing? Dharya?
Yeah. Yes, sir. Yes, sir.
So mark the points and now put your object at 2F1. Put your object at 2F1. This is our 2F1. Sudhamshu, have you done your homework? Sudhamshu and Siddhisri.
Sir, uh, so I have to draw this with a compass, right?
Which one? The lens.
Yes, sir. The lens.
See, your diagram has to be neat and clean. So
Okay, sir.
if you can use other things
Sir, for now, can I do it with a pen,
like this, so
like
that would
rough?
be good. You can use a compass also. So, however, it's advisable to use the compass.
Okay, sir.
It's advisable that you use a compass over here. See, all the refractions or all the bending of the rays, they will be shown from this vertical line. See, all the refractions are shown from the vertical line passing through the center. Now, if I draw here again the same two rays I have to draw, I will draw a ray of light passing parallel to the principal axis. So here we have a ray of light passing parallel to the principal axis. Then from here, the ray of light bend toward focus. So the ray of light bends towards focus, passes through focus here. The second ray of light we will take to be passing through the optic center. So from here we start, and we can take the second ray of light passing through optic center. And you see the two rays, they meet exactly at 2F. The two light rays, they meet exactly at 2F. So this will be possible only if you are taking proper measurements. If you are taking your proper measurement, then only you will be able to get your ray diagram. So this is your A, B, and here you have A dash and B dash.
Sir, the third diagram of homework I got, sir.
Yeah, which one?
Sir, this last lab.
What happened?
Sir, for homework you asked, no, sir. So the third one also I drew, sir.
Okay, third one you draw, this one. Yeah, I told you to draw for the object at 2F. Okay. And Siddhisri?
Sir, glass lab.
Okay. Okay, Siddhisri, are you not able to turn on your camera? Sudhanshu, you are not responding. Sudhanshu, what about
Yeah,
your homework? Have you done?
sir, I'm not done with it.
Not done. Why?
Sir, like I
Please
actually forgot.
do it. Do it. I will be checking it on the regular basis. Whenever I give you any homework, so you have to do it. Okay.
Okay, sir.
So these diagrams you have to draw right now. Are you drawing them?
Yes, sir, I'm done with it.
Sudhanshu,
The
are you
size
drawing
is
the
the
ray diagram?
same size.
Yes.
Yes, sir.
So it's same size, right?
Yeah, it is the same size. So object at 2F, we will be writing the image characteristics. Okay. So in the image characteristics, our first point is nature. So nature is real and inverted. It's real and inverted. What is the position where it is formed?
At 2F.
Formed at 2F. Okay, so image is formed at 2F. And what about its size? It's same size as the object. So these are the characteristics. When the object is placed at 2F, the image will have the following characteristics. It's real and inverted, formed at 2F, and it is of the same size as the object. Got it? Okay. So see, now the next ray diagram we will be drawing here. The next ray diagram, in the next ray diagram, we will be putting the object between F and 2F. And again, we will take proper measurements with our scale. Always use your scale, compass, everything to have a proper image. Okay. So let us see. The next one, when the object is placed between F and 2F. Sudhanshu, are you drawing? Sudhanshu?
Yes, sir, I'm done.
Okay. So if you can draw it, place the object between F and 2F. Place your object between F and 2F. See? And also draw the optic center. You can draw the vertical line here with the help of dots. You can take this to be a dotted line, or you can also draw it to be a complete line. Okay. But it looks good if you draw a dotted line from here. To obtain the optic center, if you use a dotted line, so let's say you can draw it like this. So in this way. Now you obtain your optic center. Abhinav, are you there? Abhinav, Aryan, Sudhamshu. There you are.
Yes, sir.
Yes, sir.
Please do not turn off your cameras. Be there with your camera on. I'm not every time looking at your camera, but at least you should be there. It seems that you are there. Otherwise, it seems that you have gone somewhere for a tea break.
So we are there.
So again, the same way, put your ruler something like this. Here I'm taking the focal length to be 3 centimeter. You can take 4 centimeter also, whatever your notebook permits. So here I am taking the focal length to be 3 centimeter. So this is our F. This is 2F. Here also you have F. And here is 2F. Okay. So now you have to keep your object anywhere between F and 2F. So keep your object anywhere between F and 2F. Again, mark the points. This is your F1, 2F1, F2, and 2F. So let us have a ray of light passing parallel to the principal axis. And another ray of light passing through optic center. So the ray of light that passes through the optic center, it passes undeviated. And the ray of light which passes through the focus, the ray of light which passes parallel, it passes through the focus. So you can observe that the two rays of light now meet ahead of 2F, beyond 2F. So for drawing any ray diagram, we need minimum 2 light rays. So here we have obtained the image. We obtain image here. So this is our object AB. Here you have the image A dash, B dash. So Siddhisri, what type of image is obtained here? Is it a real image or a virtual image? Siddhisri, is it a real image or a virtual image? Dhairya, is it a real image or a virtual image?
Sir, it's a real image, sir.
Okay, it's real image. So here, this is the special case where we have used the object is placed between F and 2F. We have object between F and 2F. So if the object is placed between F and 2F, so you can obtain the image characteristics. Now, there Abhinav will tell the image characteristics. Abhinav, what are the image characteristics?
Sir, it's real and inverted.
Okay, it's real and inverted.
Position is beyond 2F
Okay, it's beyond 2F.
and it's enlarged.
Enlarged.
Size
Very
is
good.
enlarged.
Okay, size is enlarged. It is beyond 2F. And its size is enlarged. Okay. So these are the characteristics of the image when the object is placed between F and 2F. You have okay. So we have drawn 3 cases right now. Actually, we have drawn 4 cases, but for today we have done 3 cases only. In these 3 cases, we have seen when the object is placed beyond 2F, when the object is placed at 2F, and when the object is placed between F and 2F. The next diagram, I'll leave you, just draw it, keep the object at F, and let us see where, keep the object at F and see, let's say, where will the image be formed. So, there, can you show your previous diagram?
Yes, sir. 1 minute. Sir, I've made a rough diagram with pen right now. I'll.
Okay, show it. Show it.
Yes, sir.
So, don't you have your compass and all right now?
No, sir, I don't have it right now.
So from next class you should, okay, just stop that blur.
Yes, sir. 1 minute, sir. Yeah.
Okay, so this is the one. Okay. Do make your arrows. Make arrows in the ray. Show it
Okay,
once.
sir.
Uh, that was the one error. You can. Okay, so you need to make the arrows,
Okay, sir.
and okay, that's the only thing. A, B, and here you have A dash B dash. Fine. Aryan, have you done the diagram?
Yes, sir.
Yeah, show it quickly.
Sir, this diagram of previous, sir.
Yeah, show the diagram.
Sir, does the object come at infinity?
Yeah, the rays of light will not meet, so it will seem to meet at infinity. Okay, so this one is for, okay, uh, uh, no, this diagram is incorrect. You have placed the object at 2F and you are getting a small image. See, the reason is that you have not made proper measurements. The focal length on both the side of the lens should be the same. Yes, Aryan? So
Yes, sir.
take your scale and with your scale take proper measurements.
Okay, sir.
Okay, so from next time you have to correct these diagrams as a homework and redraw them. Right? I observe that your focal lengths are not the same. On the left hand side and on the right hand side, your focal lengths are different, and that is why you are not getting a correct ray diagram.
Okay, sir.
Okay, okay. Thank you, Al. Anyone else who has completed? Nija, have you completed?
Yes, sir.
Okay, just show it. Yeah. So this one is for object at F. Okay, the previous one. Okay, thank you, Nija. Yeah, Abhinav, just 1 minute. This one beyond 2F, then okay, just hold for 1 minute. At 2F. Yeah, see, you have drawn at between F and 2F, right?
Yes,
Uh,
sir.
okay, redraw it. It seems as if the rays of light are meeting at 2F only. So
Okay, sir.
redraw it. Okay, redraw it. And this one is correct. Okay, last one is correct. So you need to redraw one of the ray diagram. Yes, Abhinav?
Yes, sir.
Okay. So let's move further. So here we observe that if you take a ray of light, sorry, let's first make our focus and everything. Let's make focus. You see, you have to measure them properly. Like, see, I'm placing it up. My 6 is at the optic center. So I'm taking 3 centimeter to be the distance between F and 2F. So it's like this. Here also it will be the same. If I take wrong measurements, so I'll be getting wrong answers. Okay. So first take the points, mark the points over there, and then you can proceed. So write the points here. This is your F1. This is 2 F1, F2, and 2F. So now we have to put the object at F1. To put your object at F1, and let us have two light rays moving from here. So you have two light rays which move. One of the light rays parallel to the principal axis, passes like this, and then the ray of light bends towards focus. So it goes, passes through focus. This is the first ray of light. Then if you draw the second ray of light which passes through the optic center. So you observe that the two light rays, they are parallel to each other. Okay. Even if you extend them backward, so then also they do not meet. If you extend from here backward, if we extend from here backward, so the ray of light, they do not meet. The ray of light, they are parallel to each other and they do not meet. So this is just the extension of them which I have produced in the backward direction. They are not the actual rays. So the ray of light, they do not meet. Here also they are not meeting. So if they do not meet, we assume them to meet at infinity. We assume the light rays to meet at infinity. We'll say they meet at infinity. Got it? So understood. Okay. What are the characteristics that we can put here for the image? Yes, Ayonija, what are the characteristics that we can put?
So the image formed is virtual and erect, and it is enlarged, and image position is in at infinity.
Okay. So see, many students, they are confused about it, that what to write. Should we write a real image or a virtual image? Okay. So first of all, our answer is that the image formed is real and inverted. We say the image is real and inverted because we are assuming here that the light rays are actually meeting at infinity. Just like you say, we have earth and sky appear to meet at horizon. Okay, Earth and sky, they appear to meet at horizon, but here we have the light rays going parallel to each other. The light rays which are parallel to each other, they are assumed to meet at infinity. They are assumed to meet very far off. Just like we assume that if you have parallel light rays, so parallel light rays, if they are coming towards the lens, so the parallel light rays, they meet at a certain point. If they are coming from very far off, so we take the light rays to be parallel, even if they are coming from the same point. So here also we have, if the light rays are moving, so to infinity, they are supposed to meet at infinity. So the image formed will be here real and inverted. And so if it is real and inverted, then why are we not able to observe the image? Where is its position? So its position is at infinity. We say the position of the image, position is at infinity. The image is at infinity. Okay. And what about its size? Then what can we say about the size? Yes, the
Sir,
size is
it's
highly enlarged. So if an image is highly enlarged, okay, if an image is highly enlarged, then you will not be able to observe that image. This is also, okay, I'll show you any image and I will enlarge that image, okay, but you will not be able to identify. Let's say here, I'll show you one example. Suppose I am taking the image of a lens only. Okay. So here I have taken the image of lens. This is a lens. Okay. Now everyone, all of you can see that yes, this is a lens, and this one is a convex lens, right? But what if I zoom it a lot? Okay. So here I have zoomed it just this much, but if I zoom it even bigger, so will you be able to observe it as a convex lens? No, we will not be
no,
able to
sir.
observe it as a convex lens. The reason being that it will be highly enlarged. So this is just this much. Can you say that this is a convex lens if you have not observed it earlier? No. So in the similar way, we see that if the image is formed at infinity, it is highly enlarged, and that is why we are not able to observe it. The image is not observable because it's formed at infinity. Okay. So all the ray diagrams you will be completing. There is one more ray diagram just when the object is placed between O and F, that is optic center and F. So that is your homework. All these 6 ray diagrams are there. When the object is at infinity, then all the ray diagrams you have to complete with object between optic center and F. So if you can complete optic center and F, that will be very good. Okay. Else I will be doing that in the next class.
Sir, could you show one of the yesterday's diagrams, sir? That only one
Glass lab.
diagram I don't have.
Glass lab.
No, sir, glass lab I have, sir. That I drew.
Okay, just 1 minute. Let me show you.
Sir, in the last case, the image will be formed virtual and erect, na?
So the
Yeah,
second
in the
page.
last one, the image formed will be virtual and erect. Okay, so you are talking which of these ray diagrams? So yesterday we had drawn all these ray diagrams.
So the second
This,
one, sir.
this one,
1 minute.
you had this one, and this one.
So this
Okay,
one.
this was your first one, glass lab. Then you had lenses. Then you had this.
So
And after this, you have the image
sir.
formations, these ones. When the object is at infinity,
So the previous page. The third page, sir.
this is the third one, and this is the fourth one.
So the third I completed, sir. Yes, sir. That's also.
This one, Okay.
Sir, this I didn't. This I don't have. Sir.
Okay. So I'm
Yes.
just sending it, and I'm just sending it in the group. Okay. You can go
Okay,
from
sir.
there. Okay.
Please
Bye.
share all, sir. Then I'll
Okay.
see.
Okay. Thank you.
Thank you, sir.